Well, hi everyone, and welcome to our webinar series. My name is Jesse Flott, and today we are going to be talking about the VEX Vision Sensor. So the Vision Sensor is a brand new sensor from VEX. It was introduced along with the V5 system. It is a brand new sensor that is capable of tracking colored objects. So previously, you had sensors like the ultrasonic rangefinder, where you were able to track the distance from the nearest object, but you couldn't really tell what it was if it was the right object. With the vision sensor, the robot now has a sense of color inside of the world. It can track differently colored objects. Specifically, it can track up to 7 different what are called color signatures. From those color signatures, you can also track up to 8 different patterns of color called color codes. So instead of just tracking a red object versus a blue object, you could track an object that has a red stripe, a blue stripe, and then another red stripe, for instance. And then that way you can find specific markers or for specific goals, objects that are inside of the world. Whenever the robot detects an object using one of these color codes, it is able to provide the XY coordinates of it. And by XY coordinate, that's not like XY coordinate in the whole world. That's the XY coordinate in the frame or the field of view. So your vision sensor has a limited field of view. We'll see that here shortly. And we can see where that object shows up there. We also get the width and the height of the object. So how big it is inside of that field of view. With that information, you can infer how close or how far away the object is if you know its relative size. The vision sensor is trained over a computer and then connected to the robot. So, whatever colors you want it to track, you first train it, you first configure it, might be a better word, using a utility on your computer. And then the robot gets that information passed back to it whenever it's driving around. It does connect to a smart port on the V5 robot brain. The resolution of the camera, that frame that I just mentioned, is 316 pixels wide by 212 pixels high. And then it also has adjustable brightness, which makes it more versatile across different lighting environments. So as I mentioned, a big thing that you want to keep in mind with this sensor is something called field of view, which is just understanding how the sensor sees the world. So here I have on the top a picture of my robot. The vision sensor is up top and it's looking down at a red cube. Okay. The vision sensor from its vantage point also sees the red cube, and you can see, based on the orientation of the robot, the surrounding area and things like that. So whenever we talk about the width and the height of an object or the XY coordinates, that is all relative to this frame, this picture, or this field of view. So keep that in mind moving forward. Okay, so to get started with the vision sensor, one of the first things that you'll need to do is to configure it to train these different colors. Doing so is a relatively straightforward process, but there are a number of steps. The very first step is to connect the vision sensor to your computer using the micro USB cable. Okay, so if you look at the bottom of your vision sensor, you'll notice there's 3 different ports there, a USB port, a VEX port, and a V5 port. To train it, we will do so over USB. Um, Next, inside of the training process, we have to add the vision sensor to the robot config screen of VEX Coding Studio. So I will actually show these steps after I go over them in the slides. I'll bring up the utility and show all this, but I do want to make sure that these steps are all documented for whenever you play it back or try to follow along. Okay, so you drag a vision sensor into the robot config screen. That allows you to give it a custom name. It allows you to set which port it's connected to, all important stuff. But then also there's the small gear icon in the bottom of the config. If you click on that, then it will launch something called the Vision utility. Okay, so when the Vision utility appears, it has tabs for uh, colored objects and also codes. By default, the object screen should appear. All right. Your vision sensor may have already been trained. It may have some training data. If you want to train it, you can hit the Clear All button, or you can individually clear each signature that is inside of there. All right. Now, to begin to train your vision sensor for a custom object, what you want to do is aim it so that the field of view is prominently facing the desired object. Okay, so solid colored objects work best here. And then, almost as if you were drawing a square in Microsoft Paint, what you do is you click and you drag a square over top of that object. Now, this is important because a colored object isn't actually one color. Depending on how light hits it, depending what type of light hits it, it's actually a range of different colors to the camera. Okay, we might identify this red cube as red, but it sees a number of different hues, different color codes, uh, whenever it looks at all of the pixels that make up the cube. So drawing a square over top of it says, hey, I want this range of colors to be defined or to be stored. Okay. Um, while you are aiming the vision sensor at that object, you can press the freeze button. And what that will do is that will freeze the frame. And that way it won't move around on you. And then you click and drag that square over top of the object. Once you've drawn a good square over top of the object, you can choose one of the set boxes on the right side. So check one of those or fill in one of those. And what you should notice is that the frame immediately gets filled with a box and also a semi-transparent layer that that allows you to see how much of the cube, how much of the object is being recognized by the color signature. Okay, so if after you press the set button, you only get a really spotty coverage, that might mean that your initial square wasn't big enough. But also, you can adjust it. If you find that your bounding box, that the square here is either not inclusive enough or too inclusive, then you can use the slider to the right of the signature to increase or decrease the tolerance. All right. And then another good thing is to change the default name of the signature to help you remember what color is stored inside of there or what type of object. These names have to follow the same names as variables in VEX Coding Studio. So all one word, letters, numbers, and underscores. And then again, it's really helpful whenever you're coding because you'll be using these signatures in code to name it something descriptive of the color that's being stored. So sig underscore red is a pretty good name for storing a red color signature. All right. If you click the freeze button one more time, it will unfreeze the frame, and then you should be able to move either the camera or the object around and observe how the vision sensor detects it. Okay, so as it moves around inside of the frame, you should see how the bounding box changes, what part is colored over, see how the different lighting affects it, and then imagine how your robot would want to detect this object, the different distances, the different angles, and make sure that you're seeing the desired amount of coverage. The other thing that you can affect is there's a brightness controller. So if you need to brighten up the frame, you can make that adjustment inside of this screen too. And then uh, one very, very important thing is whenever you want to save your changes, there's no save button inside of this utility. So make sure that you close it. Okay, so after you're done making changes, close it before you disconnect it over USB, and then it will save those configuration changes to the vision sensor itself. So that's an important thing to know, to remember, is that this configuration does get saved on the vision sensor itself. All right, so to look at a little bit of the programming, the number one command that you want to learn and take away if you're going to work with the vision sensor is the take snapshot command. All right, so notice here inside of this program on line 9, um, I have the vision sensor.take snapshot command, and it is specifically embedded inside of my loop. Okay, so some sensors continuously provide a stream of data to the robot, different ones that um, connect to the triports and things like that. With the vision sensor, though, you have to basically intentionally tell it, go fetch. Okay. So the take snapshot, you can kind of think of the go fetch command where it goes out, it takes a snapshot, and then it looks for signatures based on what you specified in between the parentheses. So with this take snapshot, we have it looking specifically for the data that's stored in SIG-RED. All right. And then we have an if statement, vision sensor dot largest object dot exists. Okay, so basically, if it was able to find an object of sig red, if it was able to find a red object, then pick the biggest one in the case that there's more than one, and then print to the V5 screen the different dimensions of the robot, or sorry, of the object. So if it finds an object, it's going to print the Y, the X, the Y, the width, and the height. And if it doesn't find an object, it's going to display a message, color signature not found. Okay, so if we run that code on the robot, what we should be able to see is that whenever the robot detects an object on the screen, we get an idea of what the X and Y starting points are for that object, and also how wide it is and how tall it is, the width and the height. All right, so now I do want to actually demo a little bit of this live. So I have VEX Coding Studio open. My programming language right now is VEX C++, and I've dragged a vision sensor into my robot config. All right, so I can give it a name, like vision sensor. I can give it a port. You can choose any of the smart ports that aren't taken up by something else. And then if you choose to click on that little gear, it will bring up this vision utility. All right, and right now mine is black because it's just pointing at my table, but I can actually move it around and I can have it facing these 3 different colors of objects. All right, I don't want to have to try to hold that still, so I'll press the freeze button. And I'll start with red. I'll click and drag a square over top of my red cube. I'll choose set, and you can see immediately it begins recognizing SIG1 as that color range. I think I could safely increase it a little bit to pick up some more colors there. All right, and then I'll change the default name to SIG Red. All right, I can draw another box if I want to around another one of the objects, say blue. All right. And so what to be careful of is if you drag your slider too far, you start to pick up unwanted colors from the environment. So in addition to having good coverage of your object, also make sure that you're not capturing colors that show up inside of the background. All right. And I'll also change the name of that to Sig Blue. Now, if I unfreeze it, I can see that my robot, specifically the vision sensor, is able to detect sig red and sig blue as I move it around. So that's pretty cool. Not only can it, uh, you know, give me an idea of how far away, but it can also tell me which object is which. It can find the red object versus the blue object, which is super helpful for a ton of applications. And if you're thinking about using this inside of a competition, you can imagine how you might use this to find a game object or to be able to shoot at a goal or locate a different goal. Depends on the different games, but there's certainly a ton of applications to make your robot pretty smart here. All right. Now, being able to see the X, Y, width, and height values on the screen is pretty helpful, but I think we could actually do something a little bit cooler. We could use those values to draw a square on the V5's screen. And so that's what this program does. So this program we call Draw Blob. Historically, inside of the camera world, inside of the vision sensor world, that collection of data that you get back from a colored object, X, Y, width, and height, is sometimes called a blob. Don't ask me why, but that's what it is. And so what we can do is, since we have those values, we can draw a square of proportionate size on the screen. So here we're taking a snapshot of the red object. We're looking for it, and if it exists, we will draw a square on the screen. So what that looks like is right here. We have a bounding white box that shows the full resolution of the vision sensor. Um, the resolution is smaller than the full screen, so uh, this box gives you an idea, a more relative idea of the size. Okay, and then as you move the colored object around, you should be able to see this red square shrink and grow and move around proportionately inside of there. And so that really will help you to understand how the vision sensor sees the object, not just how you see the object. Uh, what lighting, what angles, what different distances affect how it is picked up. All right. And then I'm sure that, given the competition applications for the sensor, you want some idea of some code that helps you there, not just displays to the screen. So here I have some sample code that will allow you to program your robot to turn toward the blob. How this works is if the object is detected, what it does is the robot tries to turn to be centered on that object or to be centered on that blob, right? So we know the width of the field of view for our vision sensor. Whenever the robot detects an object, we can find the width of that object, and we can have our robot turn to that point. Okay, so that's what this code does, is it will turn to the left or the right, depending on if the object is to the left or the right. The other thing to notice here is we've introduced something called an offset. An offset, as we're using it here, is just a margin of error. So it makes sure that it is centered on the object plus or minus 15 pixels. Okay, so you could make that smaller, you could make that bigger, but we're just saying, if it's within 15 pixels of being in the center, then that's good enough for whatever we want to do next. If that's drive forward and pick it up, if that's aim and shoot, whatever the case might be. So you could change that offset to be more precise. The only thing to be careful is if you don't have any margin of error, then you can end up trying to correct and counter correct for a long time unless you do a proportional uh, loop. So you could do a proportional speed to turn towards the object, so it slows down as you get closer. That code could actually be shorter, but might be a little bit less intuitive. All right. The other big thing I want to discuss with the vision sensor is the idea of color codes. So this is again those patterns of color. So I don't know if you noticed whenever I was training my vision sensor, but whenever I trained it for red, it picked up the red cube and also a red USB cable that I have. And so if my robot were to track the red USB cable versus the red cube, or a red gear on my robot versus the red cube, that would be something that I could call a false positive. It's the color with the right object, but it's not the right object. By looking for a specific color pattern, you reduce a lot of those false positives. Okay, so whenever you want to configure a color code, the first thing is that you have to have more than one color signature set up. So whether that's blue, green, yellow, whatever distinct colors that you set up, but you have to have multiple. And then go ahead and click on the codes section of the interface. Inside of the text field, you can give your code a name. I highly recommend using a name again that is descriptive of the data that it's holding or is descriptive of the pattern that you're using. So here, code underscore red underscore green, pretty good name. And then just to the right of it, the way that you dictate the pattern, the way that you dictate the order of the pattern is by typing in the signatures in order. So here we have sig red, comma, sig green. And so now the vision sensor will look for codes where a, uh, a red blob is followed by a green blob. So notice in the top screenshot, before we added that, it detected two separate objects, sig underscore red and sig underscore green. Notice in the bottom box that it is all bounded by one box. Okay, it's treating it as one object or one code now. Okay, and then the other thing that's cool is once you have um, configured a color code, uh, the objects detected will have a idea of angle. Okay, so here, if you can see it, it says the angle is minus 88 degrees. So it can detect that, hey, I found the code, I found the pattern, but it's rotated 90 degrees with red on top. Okay, so all of that is data that you can use inside of your programs to correctly orient the robot, to be able to orient a manipulator, to be able to pick up an object correctly. All of that makes for some really robust decision making for your robot. All right, so that's our quick crash course in the VEX Vision Sensor. I hope it is helpful to you. As always, feel free to let us know any questions or any requests that you have about future webinars. And then be sure to check out our different training opportunities that we have on our website. All right, thanks everybody, and have a great rest of your day.